All right, example number 3. And I'm going to tell you it's very similar to example number 2 in that we're dealing with the product rule. I don't want to make up a new rule, but this is a triple product rule, I guess you can call it. And basically, you just kind of got to go through and make sure that you take a derivative of each thing individually. What I mean by that is this. Check this out. What we have is we have a function here and a function here. And if we just had that, and I'm going to cover up this thing right here, this would be basically the previous problem. But we have this extra thing right here, and that's the tangent of x. Okay. So before I get started, let me double check with let me confer with my handy dandy cheat sheet. And I had a sine of x, so I'm going to remember that the sine of x is the derivative of sine of x is equal to cosine of x. And the derivative of tangent of x is equal to secant squared of x. So I'll put a little note to remind myself. Note that d dx of sine of x is equal to cosine of x. And also that d dx of tangent of x is equal to the secant squared of x. All right, now we're going to do the triple product rule, and it's basically the product rule, just with a third thing. So what I'm saying here is I'm going to go through this. I'm going to take the derivative of the first and keep the second two. And then I'm going to put a plus sign. I'm going to take the derivative of the second thing and keep the other first and the third thing. And then I'm going to take the derivative of the third thing and keep the first two. It's basically the product rule. I don't want to slow it down and all of that kind of stuff. And if you do the product rule slowly, then you realize, oh, wait a second, I understand where he's coming from. So we're trying to find d dx of y is equal to. All right, I told you that I'm going to do the derivative of the first thing. There, that's the derivative of the first thing. Or at least I didn't figure out what the derivative is, but I've noted down that I plan on taking the derivative of that first term right there. And I'm going to just straight up write down the other two terms. In fact, I think the direction I'm going to take on this is I'm going to say plus, but pretend I don't have enough room here. I'm going to take the next one down. So I'm going to say, all right, now I'm going to keep the first term, and I'm going to go d dx sine of x times the tangent of x. I apologize for me writing it in this way. I just feel like you might be able to understand it better when you see what I'm doing here. All right, so I've got x squared sine of x times d dx of the tangent of x. All right, there, I'm done. So actually, all of these should have been in one long continuous line, but I put them vertically, and the only reason why I did that is so that way you can see that all I'm doing is I took the derivative of the first thing, and I kept the second two the same. And then I took the derivative of the second thing, and I kept the other two the same. And then I took the derivative of the third thing, and I kept the first two things the same. All right, so let's get some room here. And then in the end, I'm going to add up each of these things. All right, so the derivative of this is pretty easy. Let's see. This is 2x, and then the other two things. There's sine of x, tangent of x. And the derivative of this is, well, we know that derivative of sine of x is cosine of x, so I have x squared cosine of x tangent of x. And then over here I have x squared sine of x times the secant squared of x. Oh, excuse me. All right. And then what I'm going to do is, let me see if I can simplify this a little more. Let's see. I know that the tangent of x is really the sine over cosine. And if I multiply this by a cosine of x, then that basically kills that thing. So essentially what I'm saying here is this right here is just sine of x. And then I guess my plan is to add them all up. And I'm going to pull out like terms. And I know that there's at least one x in all three terms. And there's at least one sine of x in all three terms. So I'll pull that out. So I have x sine of x. And then what is this term missing the x sine of x? That would be 2 tangent of x. And then this thing right here, missing the x sine of x, would just be an x left over. And then I'm going to put a plus sign because I'm telling you I'm adding all of these terms up in the end. I'm basically collecting all of the derivatives after I'm done with them. And then this would be pulling out the x and the sine of x. I'm left with an x secant squared of x. And to be honest with you, I actually think that that's about as simple as you can make it. And so that is going to be my answer.